Hello everyone, welcome to our version control workshop. We're briefly going to go over the basics of version control, and we're going to be using GitHub, SourceTree, and we're also going to be showing you how to use these tools with Unity. However, feel free to follow along even if you're not doing a project in Unity, as almost everything will be just as applicable. So, before we get started, you're going to want to go make a GitHub account. So if you want to go to github.com, you can go make an account there. That should be pretty quick. And then also, we're going to want you to go download SourceTree, which is going to be our Git interface. And you can go right here, sourcetreeapp.com. You're just going to want to download that. So go get those things and then come back and we'll get started. All right, so today we'll be working with Git, GitHub, and SourceTree. So what are the differences between all these things? They're all sort of, pieces of the same thing that we call version control, but they're all separate and they're all necessary. So we'll start with Git, because Git is the most integral part. Now, Git is software that grabs files, anything on your computer like text files, code especially, but it could also be images or whatever. And it parses these files, it will compare them and see if it could find differences. So, for example, if you've got, let's say, some text file on your computer and you add a line of it, that one sentence like hello world or something like that, and you want to share that with somebody and you want to use version control to do that. And so this person has a copy of this file on their computer as well. And they can say, oh, even though it says hello world, I'll enter in a couple lines later and put goodbye world or something like that. And so Git is a piece of software that says, oh, you've got this file and your friend also has this file on their computer and your versions aren't the same. So I'm gonna read through all of them and try to combine these files if I can. If not, then I'll let you know they're not the same and allow you to merge them yourself. So at the core, Git is just used to share code and other files with groups of people. Used for collaboration on projects. And then it will also try and separate these files, compare them, and merge them together if it's possible. So what's SourceTree? Well, SourceTree fundamentally is just an interface to Git. Git is written as command line. So if you have a terminal or like a Windows command prompt or bash shell or anything like that, you can use these just to type in stuff for Git. So you could do like git commit, git push, git pull. It's all command line arguments. But if you don't want to do that and you'd rather just work with an interface that has buttons and pretty pictures, you can use SourceTree. There's a whole bunch of different Git interfaces, but SourceTree is the one we'll be using today because it's one of the most common. So finally, GitHub. GitHub is the final piece of the puzzle. And GitHub is really just used to host content. So if you want to share a file between yourself and your friends because you're working on a project that you're coding together, what you do is you store the code files on GitHub. They'll host your repositories. That's what a group of files is called in Git. It's called a repository. And you use GitHub to share it with people so it's easy for them to contribute to your project. And it's also a place where you could find other people's projects to contribute to if it's open source. So with these three pieces of the puzzle, we'll finally have everything we need to start doing version control. So first I'm going to show you how to set up a repo or repository like I mentioned earlier. And so this is just going to be the space or like the folder on your computer that stores all the files that you want to share with someone else, right? So to create this repo, I'm just going to hop onto github.com like I said earlier. So hopefully you have your account made. I'm just going to sign into mine. And we're going to create a new repository. There's a few places you could find that. There's a big green button right on the home page when you log in. You could also do a create new up here and do new repository. So there's several ways to do it. We'll just hop down here. And so we're going to want to give our repository a name. So it should be something useful. Like I said, this is where you're going to store all of your files for a project that you're going to share with others. So let's name our example one, version control workshop 3, 4. There we go. And so that's super descriptive, and we'll just say Cool. So now someone who reads this will know exactly what it is. Now this is going to be a public repository, so anyone can view this. And if you're watching this video online, feel free to see if it still exists. But this just means that anyone can freely see your repository and see all the code in it. That does not give them the right to contribute to it and make changes, but they can view it. You can also do private. However, you'll need to have a coupon code for that as a student, or pay for it, or a variety of other ways. One final thing before we actually create this repository. Since we'll also be doing in this tutorial how to set up repos with Unity, we're just going to add a Unity git ignore. And so you say add git ignore, search for Unity. To go into this briefly, a git ignore is sort of like a text file, which is used to tell Git on your computer certain files that you'll want Git to ignore. For example, in Unity, you'd want Git to ignore things like the files that tell Unity how you want your editor to be set up, like where you want the inspector, where you want the scene view. All of that stuff gets stored in a file that gets put in your project folder. However, that's not something you want to share with other people on your project because that's your personal setup. So there's a bunch of different files that Git doesn't really need to share across a repository with other people. So adding a Unity git ignore is super helpful, and there's already one set up for you on GitHub. You could certainly create your own as well. Again, it's basically just a text file, but for now we'll be using the GitHub's git ignore for Unity. Okay, so now we're all set. We're going to create a repository, and it's going to bring us to this page here. You'll see up here, since my name is Diamond Slice on GitHub, see your name / the name of the repository. And if you look at the URL, that's also how you can find it. So now that we've got this, we've got where it exists online. This is where it exists on GitHub. Now that we have this, we need to get it onto our desktop in SourceTree. So I'm going to go to this clone or download button here. And then here you find this is the URL specifically for this repository, the location that my files are going to be stored on GitHub's network. So we're going to click our little clipboard button here. So now that we have that URL on our clipboard, and now we're going to go open SourceTree, which hopefully you've already downloaded now. And if you're just opening up SourceTree, it'll look pretty blank. This is just a project, everything about a project. If you haven't added one yet, this will be a blank screen. So now that we've got SourceTree open, one thing, if you just downloaded it, first you're probably going to want to go into your Tools and Options menu here. And then you're going to want to enter in your full name and your email address here. This way, SourceTree knows that this is the information you use to identify yourself. It does not exactly have to match your GitHub account information, but that's usually good practice to let it be the same email and name. So just enter those in there. Now that we've got our clipboard as our URL, we're going to hit the Clone New button. So what this is going to be doing is setting up a folder on our computer to store all of our files in, and it's going to specifically look at the file online on github.com to know what files it's going to store. So in the source path/URL, we're going to paste that URL that we got from github.com. If we click in the destination path, we can set up where we want it to store this on our computer. So for example, I'll just put it in the Documents folder. I'll make a new folder called Version Control Workshop 4. And so now all of the files that we use in this project will be stored on my local computer in that folder. Yep. Cool. So then we hit the clone button, and you'll see it'll grab all that stuff online off github.com. There's nothing in the repo yet, so it downloads it super quick. And now you see nothing to commit here. Okay, so now we've got it on our computer. Super great, super useful. Just to give you a little bit more information on the SourceTree interface before we move on. Right now, this is where it would be showing any files that I had added to this folder or any files that I had changed, anything like that, and that's under the File Status tab down here. Also super useful down here is the log history. This is what you saw when I first opened the program. This is going to be showing you all of the different commits, which I'll get into soon, all of the different things that people have been contributing to this project, including yourself and your contributors, among a few other things. Okay, so now that we've got our repo all set up online and we have it downloaded on our local computer, the next step is going to be adding contributors. So if we hop back onto github.com, obviously if you're making a repository, there's a good chance you want to be working on code and other things with multiple people. And this is a little bit annoying to do through github.com, but it's pretty easy. So we're here on this repo, version control workshop 4. If you hop into settings, and then on the side here, collaborators, you could add new people. So for example, if I were to add one of my partners like that, you search by name and you can add them super easily. And you're gonna wanna do this for every single person you wanna work with. They'll also need to make a GitHub account. Again, super simple. You find their name, search it, add them this way. You can hit the add collaborator button. And that's how these people gain the privilege to push to your repository. Basically, add their own contributions, modify the files. If they aren't contributors, or collaborators rather, they can only view your repository. So do that for everybody. And we've already cloned it. Yep. So we're gonna hop. Yep. Okay. All right, so now we're gonna show you how to hook up Git with Unity. I know I haven't fully explained how to use Git. That'll be coming up soon. But first we want to set up Unity to work with Git and everything. And then after that, we'll talk about all the processes and methodologies behind using Git. Okay, so we're gonna hop into Unity. We're gonna make a new project. And we're gonna store this project in our version control workshop folder. Okay, so select that folder. We'll call this project of the workshop, exclamation point. I'm going to create a new project. All right, so we're in Unity now, and there's a couple things that you need to do to get Unity set up. And I'm going to bring up back my slides so you can see. Unity usually plays pretty nicely with Git. There's just a couple things you're going to need to know, a few settings that we're going to fix up first. So if you want to go into the Edit, Project Settings, and Editor, so that's going to be right here. There's a few things you're going to want to change. We want to change our version control mode here to visible meta files. Without going into too much detail, a meta file is basically a file that exists for every piece of data you have. So every piece of code, every picture, every 3D model, it'll create a meta file for one of these, and that'll store certain information and differences about that file. You don't need to worry about touching the meta files yourself. Git just needs to know about them. But visible allows you to see them and makes it super easier to work with. So set that to visible meta files, and then go to Asset Serialization and change that to Forced Text. Okay. So with those two things, a couple other things you want to know about Unity. You should avoid changing the same scene at the same time. So if I'm working with my friend Johnny and I have a version of this scene on my local computer and I'm adding buildings and trees and stuff to it, if Johnny is also on his computer working on that same scene and adding buildings and cars and whatever, Git will not know how to merge the two scenes, and you'll have to pick one or the other. So it's generally a good practice to not have two people working on the same scene at the same time, because one person's going to have to throw away their work. This is becoming less of a problem with newer versions of Unity, but it's still worth bringing up. Also at the same time, if possible, you should avoid changing scripts at the same time. This is obviously sort of impossible and sort of the reason that Git exists in the first place, so that you could modify the same pieces of code at the same time. But in general, you should avoid it if you can. It's good practice. If you do have to edit the same scripts, it's not a big problem, but try not to edit the same parts of it or the same lines of code, because then it can easily conflict with the other person's version, which we will get into in a bit. Okay, so now let's talk about how we actually use Git and all the key terms and methods that we need to use. All right, so when you're using Git, there's a couple stages of things to do to make sure you can get your work from your computer onto your collaborators' computers. And so if we start over here on the left of our diagram, and this will actually be what it looks like in SourceTree, you'll have a series of things that you've added to your repo or changed. So for example, if you've, in your repository, let's say you have a couple pieces of code, a couple .cs files, maybe a couple .txts, you'll see in SourceTree that you've got changes to a file. You can also, it'll show if you've deleted any files or if you've added any new files. And it'll just compile all of these things in a list, all of your changes, additions, deletions. To get them onto someone else's computer, your first thing you're gonna do is stage these changes. And what that does is it basically takes all of these things that you've done and puts them in a single place and says, yes, I want this to be my most recent additions, all right? So you stage them all. Once you've decided every file that you want to take these changes and push them onto someone else's computer, you stage them and then you hit the commit button, or you commit these changes. And so it basically takes these changes and then wraps them up into a single package. All the files you've added, all the files you've deleted, all the files you've changed, all of these things get added and wrapped up into a single package called a commit. Now that you have them all committed and ready to go, this is the most recent version on your computer. Now, to get this to everybody else, you just use the word push. I'll show you how to do this in SourceTree in a little bit, but you take these changes and push them, and then it adds all these changes on top of everybody else's. And you'll see there's sort of a graph in SourceTree and pretty much any other Git interface you use that will show you other people's commits. And so it's sort of like this chain of, oh, Chris has made a commit, on September 20th. And then Reggie has his changes and he makes a commit on the 25th. And then I make one on the 26th. And so every time you make changes, you stage them and then you commit them. And then once you have a committed package, you push it. So the important part is people can only see your changes once you push them. Staging them and then committing them is just done on your local version and is sort of necessary abstractions needed to make the whole system easier. If you use certain Git interfaces like the GitHub client, they sort of merge all of these different functionalities into one. So you use the sync button and it does stage, commit, and push all in one. However, you'll see, or you'll find rather after a lot of use, that the way SourceTree does it is pretty nice. By having several layers of abstraction, you have a lot of control of what you're doing. The important thing is just that no one can see your changes until you push them. That's the really pivotal, important step. Just a few notes before pushing your stuff off for other people to grab it. A couple things to remember is before you push, you always need to commit them. You can't have anything pushed to other computers without having it packaged in a single commit. On top of that, you want to make sure that you've actually saved all your work before you push. So for example, in Unity, you want to make sure your scene is saved, or all your prefabs, or the project. So just make sure you save everything, because you can't stage and then commit a file before it's saved. Or if you do commit it, it won't be the most recent version. You need to hit save first. And I'll talk about removing and discarding a little bit later. Okay, so now let's put into action everything I just talked about. This is our Unity project. We haven't really done anything yet aside changing from some settings. However, when we created the project, Unity generated a few files. And all these files it generated, if you remember, are going to be in our repository, that folder we set up on our computer. So if we hop into SourceTree and you go to the File Status tab down here, you'll see here, these are all of the files that Unity added. And a lot of them are pretty, gibberish looking things. But these are everything that's been added. Oh, actually, a quick note. This problem comes up quite a lot, you'll see. you see I've moved into our repository here, version control workshop 4. Our gitignore is actually outside of our Unity project file folder. And that's just because we didn't put it in there. GitHub just dropped this file wherever. But now that we've got a Unity project inside our repository folder, let's just take our gitignore and drop it into the Unity project. This will save you from some errors in the future. You can see the assets folder, library, everything in here that you recognize from Unity. Having the gitignore on this level will make sure that it actually works properly. So that's just a little snafu some people run into. You just want to make sure you do. Okay, so we hop back here into SourceTree, and you can see, again, these are all the files that it's added, and it's actually updated because there were some files in here before that the gitignore would ignore. So now that I put that in the right place, the number of files has gone down. So these are all our unstaged files, everything new that Unity has added for us. We're just going to click this little checkbox up here, and it's going to move all of them up into the staged files area. We could have also checked them individually if we wanted. You can also unstage them if you want. Staging is a very low commitment action. It doesn't really have any repercussions or anything. You can just undo it immediately. But now that all our files are staged, they're ready to be committed and put into one package. So if we click down here on the commit message, it'll start a commit for us. We could also click the commit button up here if we'd like, but just down here, we'll make a comment, and I can say added Unity project. All right, because that's really all we've done. We haven't made a game yet. We haven't done anything super interesting. We've just created a project in Unity, and it generated all of these files for us. So that's just going to be the commit message. That's what other people will see when they pull the most recent version. They'll see, oh, I added Unity project. And it's super useful. Make sure that you have very informative commit messages. That's something everyone has a hard time doing because it's very easy to just say, oh man, nothing's going right. I'll just have a very silly, not informative commit message. But you should always try to be informative if you can. So we just hit the commit button down here. It wraps all of that up, all of our changes into one complete package. And now you see up here, the push button has turned red and has a little 1 on it. If you have a newer version of SourceTree, it'll actually probably be blue. This version's a little bit outdated. However, pretty much everything's in the same location, so it should be no problem if you've got the newest version. Okay, and now if we hit the push button, you'll see this master branch and remote branch. You can ignore these for now, but to briefly let you know, one of the cool features of Git is you can have multiple branches of your repository, meaning you can have different versions of all of the files that you can that you have in your repository, and you could branch them off. And so that could be like, for example, if you're working in a game and you want to add a new feature, for example, like rocket boots or something, you can make a rocket boots branch, and all the code you're doing goes into this new branch, but it won't be in the master branch. So no one else sees that code until later on you say, all right, I want to merge this branch into the master, the one that everyone else sees. It's a really cool feature. We won't really be going into it in this tutorial, but certainly look into that once you're a bit more experienced. So we're just saying, yes, we want to push our local master into the remote master. Hit OK. Good. And so now it's asking me to authenticate my username on github.com. Cool. And so that means that my push went through, so anybody else who views this repository or is a collaborator with it will now be able to pull the new Unity project that I added. If you click on log history down here, you can now see this new commit is up there, the added Unity project commit. And this graph is super useful. You'll find as a project gets more complex, it'll start drawing out all the different commits by everyone else working on it. And it's super useful to figure out what's happening in your project, especially, let's say, if you haven't worked for a few days, but everybody else has been adding work. It's a good way to catch up, see all the changes, and do a variety of other things. Okay, so now one more time, we're going to go over all the things we just did. In addition, we're going to briefly talk about what happens after. So this is the general workflow for pushing your changes, the things that you add to a project, every single step. and I'll explain them in more detail in just a bit, but here they all are in one slide with some memes. So, like I said before, first you stage your changes. We've already done that. Grabs all of your changes, all the files that you've added, puts them into one place. You commit all those files. After that, you're going to do a thing called fetching. This is not necessary, but this is a good practice. If you're in SourceTree and you click the fetch button, this will basically show you if anybody else has added changes. It's really just good practice because SourceTree isn't always super up to date with what your repo looks like on github.com. I think by default it updates every 5 or 10 minutes. Fetch is just forcing it to update the information from github.com. It really is not necessary, but it is a good practice. It'll show you if anyone else has pushed new content since you last checked. But again, GitHub will, or rather SourceTree will fetch on its own every 5 or 10 minutes. So it's not a huge deal if you choose to do it. It'll happen automatically anyway. All right, so after fetch, you use pull. Pull is the command you use to have whatever's existing on the online remote, the repository on github.com. Pulling says, oh, like let's say my friend added changes and I want to grab those. What I do is pull his changes. So all the files he added and changed, if I pull them, they now get added to my local version, right? And so I'll show you doing that in a minute because I'll push from a different computer. The next few things we will get to in just a moment, merging. The Lenny face here is a very important step that if you don't follow, all of your teammates will hate you. Whenever you pull someone else's stuff, before you say, oh, okay, I grabbed their stuff, now I'm gonna take all my stuff and push it, you have to make sure your project or your game still works, please. It's very frequent that people just grab someone else's changes, GitHub or SourceTree will merge it on its own, and they say, oh, that's good, let me just commit it and push again and say, okay, I pushed my content, everybody has it now. If you don't check to make sure it works first, because it oftentimes will break without you knowing, somebody else is going to pull and say, oh, somebody broke the game and it wasn't me, and I'm not happy. So please make sure you always check your work. Okay, so I'm gonna go jump onto another computer briefly and make a few changes to this project so that I could show you how to merge and deal with conflicts. Okay, so now that I've pulled these changes onto my other computer and added a few things to this repository, I'm gonna show you some simple ways to deal with conflicts, as they're called. So if two people both make changes to the same file, how do you resolve which changes you keep and which changes you don't keep? So a few things. First, we're gonna take our example scene here and we're gonna try and spice it up a little bit. We've got this great cube, but I think it's really missing some class, so we're gonna put a sphere in here. And yeah, great. Okay, now that this scene's a little bit better. So we're gonna save our changes to that. And one other thing, we're gonna hop over into example script. So we've got this great printing a hello world message here. That's great and all, but not quite good enough. I think we need another print. And let's put a little goodbye message in there. Okay, great. So these are the changes. I think I've improved our project quite a bit. Now let me go push these off to everybody else. And so you see, we'll hop into SourceTree here. And see, I've got these two changes. That's my change to the script, my change to the scene. Great, no problem. Okay. And so we're gonna say, okay, cool. So those are the changes that we just added. We want everybody to know about them, so we're gonna push that. So we try and hit push and get those everybody. We get this little error here. Now if you read carefully. There's a whole lot of stuff here. It might look a little bit scary at first. It's not a big deal. If you see this specifically here, updates were rejected because the remote contains work you do not have locally. That is just a somewhat complicated and somewhat buried sentence that's basically just saying somebody else has already pushed work that you don't have on your local copy. And so, like, well, that seems weird. If we do fetch, like I said earlier, hit OK, we'll see, oh, we had something we needed to pull. So we can't push all of our changes until we have all of the changes that already exist. So if you see here on the graph, this bit here, the pink, that is the push that I did for my other computer. And since I don't have that in my local version yet, I'm not allowed to push the stuff I have. So first, let's just say, okay, I need to have that stuff first, so I'll just pull, grab their changes, and it'll be no problem, right? Okay, so I just pulled, but you'll notice that there's still a 1 up there, which might seem a little bit curious. Before you jump to any conclusions and think, oh, it didn't go through, so you mash pull again, you'll notice over here that we got this little caution sign that just appeared out of nowhere. And you see merge down here. If you go to file status, you'll see, oh, the pull hasn't gone through because there was conflicts. That's what this little caution sign means. So these changes up here, the project settings that I wanted to change, those go through no problem, but the example script and the example scene both had conflicts. And you'll see on the side here, it's trying to show us what's different. For scenes, this is just kind of a bunch of gibberish. Unfortunately, you can't really easily edit a scene through text, so this is going to be not super readable. But for regular scripts like example script.cs, you'll see up here, oh, I added print goodbye world, but it turns out that myself on a different computer, or any of your collaborators, whoever, has added a different line here in the same place. So how do we resolve these? Well, if we jump back to the slides briefly, there's 4 major things if you're running into conflicts that you have as options. You have resolve with theirs, resolve with mine, mark resolved, or just doing a hard reset to any commit. So we'll talk about each of these in order. They're all fairly straightforward. So resolving with theirs and resolving with mine is basically saying, oh, this file you made changes to and I made changes to it. Well, I'm just going to pick your changes. Ignore everything I added to this file, all the changes I made to it. Just use the one that this person has on their local copy. That's what resolve with theirs is. So basically, you're just taking the version that already exists on GitHub on the master branch and saying, okay, forget my stuff, use theirs. Resolve with mine, as it is named, is quite the opposite. It just says, well, forget whatever file exists on github.com, replace it with my version of the file. Okay? So throw away all their changes, only use yours. And so let me show you how to do those first. So if we hop into source tree, the reason I explain those first is because, like I mentioned earlier, Unity scenes do not play super nicely with version control. So I made changes to this scene, I added the sphere, but if we look at the history, the log history, you'll see the pink version, that's our other collaborator who totally isn't me. Oh, it says here they added a plane to the example scene. So if they change the scene and I change the scene, they're gonna conflict. Unfortunately, specifically with scenes only, or also prefabs, basically anything that's not code, you have to pick one or the other. You can't just merge them and take the best of both. You have to pick one or the other. So if we right click on this, we're gonna go to resolve conflicts, and we're gonna say, okay, I think that the other person made more important changes to the scene than me. I mean, I only added a sphere, but they added a plane, so that's probably way more important. So we'll just say resolve with theirs. Okay, and just gonna warn us, but you're gonna say, I don't care, source tree, I know what I'm doing. Great. Okay, only one thing left to resolve, the example script. There's a couple ways to do this. With code, you can just do the same thing of resolve conflicts and use mine or use theirs. That's fine. However, another thing you can do specifically with code that's nice is manually merge it and pick what you want and what you don't. So if I go into this script in Visual Studio here, and it's asking me if I want to reload stuff. So I'm gonna hit yes, and yes to all. Okay, so it reloaded after I pulled, and now there's all this gibberish in here they added. It's pretty simple. The stuff between the arrows and the equal sign that says head is the changes I made, and the stuff between the equal sign and the other arrows and this long commit ID is the stuff that they added. And so since I'm a self-independent, smart programmer, I can say, well, I know what I want to do. I'm going to merge this manually. So let's say I want to keep both of our changes, because I do. I think their message is important, and I think my message is important too. I'm going to delete the text that Git added here, which specifies the differences, and say, okay, great, I fixed that. It's all set. But even though it compiles now, I actually think my print message should go before theirs. So as an intelligent programmer who knows entirely what they're doing, I'm going to make the executive decision to say, this line goes first. Great. So I save that. I've done the merge manually myself, and I hop back into source tree. However, it's still here as an unresolved conflict. That's only because source tree and therefore Git doesn't know that I just made that change. Or rather, it doesn't know that that says it's resolved. You can see up here, this is how the file looks now. And so it knows that there's been changes, but I need to let it know that they're the right ones. So the same way I resolve theirs or mine, go to resolve conflicts and hit mark resolved. And it says, are you sure? Yes, I know what I'm doing, source tree, thank you. So now it says, okay, that's fine, that's not a conflict anymore. And you'll see there's nothing here that is a pending conflict. So now that we've got all of these fixes, we've got this merge in here, we're gonna go down to commit this merge, because just like staging files, you have to stage fixes, stage merge files. And when I click this, you see it already fills in text merge branch. That's just because source tree is being smart and it knows that we're doing a merge here. So it actually just adds all the conflicts into this little bit here and how we fixed them. So we don't even need to add a commit message, it's already done it for us. So we're gonna commit those merge changes, went through, you see we've got a 2 up here, so now we have 2 pending pushes, the original changes plus the merge, and we're just gonna push those. Great. So that's pretty much the full setup for most cases of having to do committing, pushing, and pulling and stuff. And so I'm just gonna bring up my slides again real quick to go over these once more. We did go over, this is the basic workflow of just saying stage my changes, commit my changes, pull anything that I need to get first from the remote, any changes my collaborators have made, and then push. That's the simple workflow, but we just went over merging. So now we've got the whole complete workflow with the descriptions of each all the way back to this slide. Here we go. This is just descriptions of all of those. So you stage, commit, fetch is just this good practice stage where you say, oh, are there any changes I need to know about? Optional. Pull the changes from someone else. Merge those changes if there was a conflict, otherwise it merges it on its own, no problem. Here's the important one, check to make sure everything still works on your end. Don't break the build. That's the Lenny face step. Then commit your merge changes if you need to, and push them. So that's the whole workflow for getting work on your computer to someone else's. It certainly seems complicated at first, but once you learn all of these commands, it's pretty simple. And again, the basic workflow is usually much more simple. This just deals with merging. Okay, so that's going to be everything you need to know to get your Unity project, or really any basic coding project, set up to work with multiple people in a group. Again, use Git, GitHub, source tree. If you need any of these slides, please come talk to one of the Game Development Club officers, or they should actually be available in the YouTube video description. Thanks so much for watching. See you next time.